For decades, engineers believed there was one place you simply couldn't build an underwater railway. Not here. Because this wasn't just the bottom of the sea. It was one of the most active earthquake zones on Earth. At any moment, the ground beneath the Bosphorus could shift by several feet in seconds, enough to snap steel, crack concrete, and destroy an entire transportation network in a single violent moment. Yet every day, thousands of passengers travel beneath this strait without giving it a second thought. Above them, some of the world's largest cargo ships sail between the Black Sea and the Mediterranean. Below them, trains race from Europe to Asia in less than 5 minutes. So how did Turkey build an underwater tunnel where the next major earthquake wasn't a possibility? It was an expectation? The answer involved sinking enormous concrete tunnels into the seabed with almost impossible precision, designing flexible joints that could bend instead of break, and solving engineering problems that had never been attempted on this scale before. This is the remarkable story of the Marmaray Tunnel, a mega project that connected 2 continents by learning how to survive the moment the Earth begins to move. For centuries, Istanbul has stood between Europe and Asia. The Bosphorus Strait divides the city, forcing millions of people to rely on bridges and ferries every single day. As the population exploded, traffic became one of the city's biggest problems. Crossing the strait could take hours during rush hour. Building another bridge wasn't enough. The only long-term solution was to travel beneath the water. But there was one enormous obstacle. The Bosphorus sits only a few miles from the North Anatolian Fault, one of the most dangerous strike-slip faults on Earth. History had already shown what this fault was capable of. Massive earthquakes had repeatedly devastated the region. Any tunnel built here would have to survive shaking powerful enough to destroy ordinary infrastructure. That challenge forced engineers to rethink everything. Instead of drilling one continuous tunnel through solid rock, they chose one of the most difficult construction methods ever attempted: an immersed tube tunnel. First, giant concrete tunnel sections were built inside dry docks on land. Each section weighed nearly 18,000 tons and measured over 130 meters long. When completed, they were carefully sealed, floated into the Bosphorus, and slowly towed across the water. But transporting them was only the beginning. The real challenge came beneath the sea. Engineers dredged a trench across the seabed with incredible precision. Every tunnel section had to be lowered through the water, aligned within just a few centimeters, and connected perfectly to the previous segment. Currents in the Bosphorus constantly pushed against the floating structures. Even a slight misalignment could delay the project for months. Divers, GPS systems, hydraulic positioning equipment, and computer-controlled monitoring worked together to guide each massive section into place. Then came the feature that made Marmaray unlike almost any underwater tunnel before it: its earthquake protection system. Instead of making the tunnel completely rigid, engineers designed special flexible joints between sections. If an earthquake caused the seabed to shift, these joints could absorb movement without allowing the tunnel to fracture. In other words, the tunnel was designed to move with the earthquake instead of fighting against it. That single idea transformed one of the project's greatest weaknesses into one of its greatest strengths. Construction wasn't only an engineering challenge, it became an archaeological one as well. While excavating stations near Istanbul's historic center, workers uncovered one of the largest Byzantine archaeological discoveries ever found. Ancient ships, roads, buildings, and thousands of artifacts emerged from beneath the city. Construction slowed dramatically as archaeologists carefully preserved centuries of history hidden below modern Istanbul. Only after years of excavation could work continue. Finally, after almost a decade of construction, the last tunnel sections were connected. Rail systems, ventilation equipment, fire protection, waterproofing, and advanced monitoring technology were installed throughout the network. In 2013, the Marmaray Tunnel officially opened. For the first
Checking
time
the
in
overhead
history,
systems.
passengers could travel directly
Waterproofing
beneath the
confirmed.
Bosphorus by rail. A journey that once depended on bridges, ferries, and endless traffic now takes only minutes. But perhaps the greatest achievement isn't how fast the trains travel. It's the confidence hidden beneath every trip. Far below the sea, beneath millions of tons of water, lies a structure built with the expectation that the Earth will eventually move again. And when that day comes, one of the world's most extraordinary tunnels won't rely on being stronger than nature. It will survive because it was engineered to move with it.